Hey guys, welcome back to day 17, and today we're going to be talking more about exceptions. Last time we talked about how you can use a try-catch block to handle an exception, but what if a method doesn't handle an exception? Well, that means the method must declare it using this thing called the throws keyword. And so if you have this exception that might arise in your program, then you're going to use either a try-catch block or the word throws to say, hey, there might be a problem here, but we're not going to worry about it until later. As the programmer, we can also throw an exception by using the throw keyword. And so instead of waiting for Java to come up with like an index array out of bounds, error or exception, we ourselves can like throw an exception when we know something's going to go wrong in a specific case. And so say like you're playing a game and you know there's no way for the score to be negative. Well, you're always like getting points, and so you're shooting, the laser monkeys or something. You're shooting the monkeys with your lasers, and there's never a way to get negative points. Well, you could throw like an exception, or you could throw an arrow if the score ever is negative, because now you're playing an invalid game here, so like stop the game, because it's not right. You don't want someone getting like a high score or super low score and like completely messing it up. So basically Java's exceptions can only tell us if we're doing something syntactically wrong or logically wrong. We're accessing something that doesn't exist, or we're using the syntax wrong. But what if something else is wrong? Like I was just saying with the video game example, but what if we like created a program for this park and we want to say, no matter what, we always want the number of trees in the park to be above 0. What if, the number of trees in the park goes below 0? Wouldn't you like to know that, as the programmer? As the programmer, I want to know if the score is negative, or if there's less than 100 trees in the park. What if, I'm a programmer, I can do something about that. Because you can control the code, you can be like, oh, if the score is negative, then make it 0. Bring it back to like a valid value. In this instance of our tree thing, we can say, oh, if we go below 100 trees, well then we want to plant some more trees. That's a method. Yeah, you can plant some more trees and you'll be back at 100. This may seem very abstract right now, but stick with me, as always, because I'm going to tell you something very big. There are many exceptions built into Java, but we can also create custom exceptions. We can create our own exceptions in Java. So looking at this chart I have up here, basically here are all the exception classes. They are all subclass of the java.lang.exception class. And so every exception out there in the world is a subclass of this java.lang.exception class. And so the exception class is a subclass of the throwable class. The throwable class has two main subclasses, the IO exception class and the runtime exception class. And these are the two that we're most concerned with, the IO and the runtime. Okay, so what are we even doing? We are going to be making hot chocolate. And so I know it's January right now. We all want to be, sipping hot chocolate. It's cold outside. And we want to be warm and cozy, and so that's what we're doing today. And it is very cold here as well. And so we are going to open our little spotlight here, open nut beans, and we are going to make some hot chocolate with our code today. So if you want to go make some hot chocolate and like pause the video to like get ready for this, yeah, go do that. Once you have your hot chocolate in hand, we are going to get ready to code. So first, let me close our little exception practice that we did before. And we are going to do File and New Project. And we are going to create a Java application. And we're going to call it Hot Chocolate. And so, chocolate. There we are. We're in the desktop. There we go. We're going to be making hot chocolate in this example. And so, you make your hot chocolate. And sometimes you sip it and you burn your tongue. It's so hot, so your body's like freaking out because this hot chocolate's too hot. But then again, you're sitting there, you're waiting for your hot chocolate to cool down, and then you go do something. You go write a thesis, and your hot chocolate is no longer hot anymore. It is room temperature, and that is what our program is going to be about today. And so we want to prevent our hot chocolate from being too hot or too cold. And so how are we going to prevent this? Well, we're going to use exceptions. And so in this program, we are going to create this thing called the temperature exception, and we're going to have an exception for that's going to be thrown if our hot chocolate's too hot, and then we're going to have an exception thrown if our hot chocolate is too cold. So this is going to involve making some more files. And so we're going to click on our little package here, do Control click to get this little menu. We'll do new. We'll do class here. And we're going to make a new class, and it's going to be called too cold exception. So it's going to be too cold in here. So we have too cold exception, and we're going to say extends exception. Here we are. And then we're going to do another one, you guessed it, for too hot. So we're going to have Java class and say too hot exception. Exception. And you can name them, of course, whatever you want, but this is nice. And so extends exception. And all you have to do is say extends exception, and boom, they're exceptions, ready to be thrown. But notice, what if I want another exception that's like a little too hot, a little too cold? There has to be a way for us to group these somehow. Like, what if there's something I always want to do, or I always want to like have in my class that has to deal with all of my temperature exceptions? Well, we can create this thing called temperature exception. So we're going to click on our package again, and we're going to do Control click, do new, do Java class, and we're going to do temperature exception in here. Hit enter, it's going to load. Here we are, the temperature exception. And basically what we're going to do is we're going to group our too cold and our too hot exceptions together. And so how are we going to do this? Well, we're going to say this exception extends exception. And then we're going to change our too cold and our too hot to extend temperature exception. And so now they're kind of grouped, temperature. And so now they're kind of grouped together. And so if I do something inside of my temperature exception, it's going to impact our too hot and too cold. We're not going to be doing that in this tutorial, but it's nice to know, okay, this is the proper way to program. You should have things grouped together, you know, have all your ducks in a row when you are programming. And you might be wondering, I'm not even going to use this temperature exception. Well, again, it's nice to have the grouping and have everything in order in case, you know, one day you want to use that exception. And why do we even create the too hot? Why do we even create these files if we're not implementing them? Like, that's the code. We just wrote the entire code for 3 files, and there's like nothing in it. Why do we do that? Well, we need to have a special way to say this is what I mean by too hot, and this is what I mean by too cold. It gives us a nice way. We can add stuff in here later if we want, but it gives us a nice way to differentiate between different problems in our program. All we need is a title and to extend the exception class. Isn't that weird? Isn't that crazy? Oh, okay, that's weird. That's so weird. Okay, if you don't think that's weird, it's weird. And so we have our exceptions. We have these problems like, okay, if it's too hot or too cold, we have the fact that those problems are there. Now we go to this hot chocolate class. And so what's the first thing we do? Well, we have to know what the temperature for the average person, you know, what is the average temperature for hot cocoa? So if we go to Google, we type in average. Okay, well, we go down here and we go ideal temperature. Here we go. Between 160 Fahrenheit and 185 Fahrenheit. And so if you want to do Celsius, that's cool. I'm doing this example in Fahrenheit. But yeah, and so we are going to create some variables to hold these values. And so we are going to do public static final double too hot equals 185. And so what does all this mean? Basically, we are going to make everything static in this class just so we don't want to have to create an instance of hot chocolate because it's kind of a weird program where we're just going to run everything in the main and deal with it there. We're not going to want to create like a hot chocolate 1, a hot chocolate 2. If we did want to do that, then we could make these variables here, you know, not static and make them set by a constructor, which we learned about earlier in the series. But we're not going to do that here because the average is never going to change. And so then we'll have public static final double, and we'll spell double correctly, too cold equals 160. And so basically these give the maximum and the minimum for too hot, too cold. If it's 185 and above, too hot. If it's 160 and below, it's too cold. And so what do we do now? How do we say, okay, I'm drinking my hot chocolate. Oh, that's too hot. I'm going to throw the too hot exception. Well, we're going to create a method where the person drinks hot chocolate, so it's drinking hot chocolate, and it's going to throw an exception or not throw an exception based on the temperature of the hot cocoa. So like I've been saying, if the temperature is greater, we'll throw a too hot exception. If it's less, then too cold exception, which we define those values of higher or low up here with our too hot and too cold. And if it's all good, if it's between 160 and 185, then we'll print out, it's all good. So how do we do this? Well, we are going to create this method. So we're going to say public static void, and then we're going to say drink hot chocolate, open close parentheses, open close curly bracket, and inside of our little parameter here, it's going to take a double, which is going to be the cocoa temp. It's going to be the temperature of our hot chocolate. So what are we going to do inside here? Well, what we just said. We're going to do if cocoa temp is greater than or equal to hot, meaning it's greater than or equal to too hot, meaning it's too hot, then I need to throw an error. I need to throw an exception. We're going to do throw new too hot exception. There we go. So we're saying, okay, if it's too hot, we're going to say it's too hot and throw that error. Else, if the cocoa is too cold, so cocoa temp is less than or equal to too cold, then we know our cocoa is too cold, so we want to throw new too cold exception. And so you might be getting errors. Why would you be getting errors here? Well, one, we forgot to add these little parentheses here. And why are we're getting a little error? Unreported exception, too cold exception must be caught or declared to be thrown. And so this is what I was talking about earlier, where you either have to throw an exception, like say, oh, this method throws too hot or too cold, or you have to do it in a try catch. And so here we don't try or catch our exceptions, so we have to say drink hot chocolate throws too hot exception. And then we also have to say it throws too cold exception. There we go. And now our errors are gone because we've declared, okay, there might be an error here. And why do you have to use this keyword throws? Basically what throws does is it says when this method is called, there's going to be a try catch like at the next level above. So I'm okay with there being an error here. When it gets, recalled inside of another method, we're going to be fine. We'll talk about this later. So if we go to our main method for now, we are going to set a temp for our, hot chocolate. We're going to say double current cocoa temp equals, and we'll just say equals 170. We have good hot chocolate right now. And then we are going to do a try catch. And so inside of the main method, we'll do this try here, and we'll do a little catch here. And just kind of put that in there, ready to go, and we'll do another catch. And this is like the little framework of our problem. And so what we're going to do here is we're going to try to drink the hot chocolate, but if it's too hot, then we'll catch the too hot exception, and we'll say, oh, it's too hot. And if it's too cold, we'll catch the too cold exception. It's too cold. Notice it's not going to fall into both too cold and too hot. It's going to either try to do it and succeed, or it's going to be too hot, or it's going to be too cold. There's never going to be a both in there. It's exclusive. And so inside of our try, we're going to try to drink the hot chocolate. And so we'll do drink hot chocolate. We're going to try to drink it, and if it doesn't work out, then that's okay because we have our catch statements. This does not work in real life, FYI. So you have this method, and you want to put in the current cocoa temp because that is what we're drinking. And then inside of our try here, we can do system.out.println, and we can say that cocoa was good. And that means like our try succeeded, we got to this line. Otherwise, it would stop doing this and go straight to our catch. And so what are we even catching? Well, we're catching our too hot exception, and we'll just do E1 here. And if our hot chocolate is too hot, we'll say system.out.println, that's too hot. There you go, and then add that semicolon, of course. And then the other exception that we're catching is a too cold exception. So we'll do too cold exception E2, and this will just be the message to. And if we get a too cold exception, what do we want to print out? We want to do system.out.println. That's so cold. It's like the Arctic. There we go. Add that double quote right there, semicolon, and we're good to go. So what does this do? Basically, we set this current temp of our hot cocoa, and we say we try to drink it. If it's too hot, then we say, oh, that's too hot. We'll print it out. Otherwise, we'll say, that's too cold. It's the Arctic, you know, if it's too cold. But if it's perfect, we're good to go. And we will actually print out system.out.println. To prove that it finished, we will say, and it's gone. There we go. So the hot chocolate is gone, and we need the semicolon for, you know, syntax purposes. And so we are actually going to run this. It's going to run, and we should get that cocoa was good and it's gone because we tried to drink it, it worked out, and now it's gone. What if we try 100? That's way too cold. So we'll press play. It'll say, that's so cold, it's like the Arctic. But of course you drink it anyway because you always drink hot chocolate, and now it's gone. What about 200? Save and play it. It's going to be way too hot, that's too hot, and it's gone. So whenever the exception, you know, it went out of bounds here, then it printed out the correct thing. And where were these exceptions even created? Well, if we go to our drink hot chocolate, we actually threw them ourselves when we knew something was wrong with the logic of the program. And there we go. We made our own exceptions and used them. And you can make these statements down here that that's too hot and that's too cold. You can make them different. You can randomize them. So you could say, okay, I have 3 statements. That's too hot. That's way too hot. And that's super hot. And you know, I could cycle through them with a random function if I wanted to add that in here. Same with that's cold. What happens if inside of my main I do not catch my exception? Like what if I literally just comment out our catch? So we have this whole catch thing, we do that. And you can't have a try without a catch, just FYI, because if you're trying something, then you need to catch it if something goes wrong. Obviously, you try to throw your ball over the fence. If it doesn't make it, someone should catch it for you. I don't know. You understand what I'm saying? And so we have this commented out now. It says we have to throw this, so we'll have to say in our main throws too hot exception, too cold exception. There we go. And we play it, and it's going to error because it says too hot exception. You know, this is where if we click here, that's where it was initialized, that's where we had the exception, that's where the error occurred, and then it was brought back to the main, which then, you know, errored, and then it went to the big system and it printed this out to the console. So that's why we have our catch. So we can say, do this other block of code so that we don't have to deal with an abnormal exiting of our program. And so we will actually put this stuff back inside here. And we're putting it back, and there we go. So what if we added a loop where we can wait for our hot chocolate to like cool down, or we can say, hey, waiter, you know, or you yourself, because you make hot chocolate at home, you heat it up because, you know, you want it to be warmer if it's too cold. Well, we can simulate this idea of like waiting for it to get colder or to like heat it up. And so we are going to add a couple things to our function if we want to do this. If we want to do this waiting for it to get cooler or to heat it up ourselves. And so we are going to add a little Boolean here. We're going to do Boolean wrong temp equals true. And we're basically going to add this huge while here that's going to say while we're at the wrong temp, then we want to keep trying to drink the coffee. And if we keep getting errors, that's okay. We'll keep getting the errors and we'll have our wrong temp here. It will stay true. And then when we get to our try and it succeeds, then we'll set our wrong temp to false, meaning we have the right temp. It's good to go. And this indenting kind of sucks, and so we can do Control A, source format, and it will set it up all pretty for us. How nice. And so what does this while loop do? Well, it says, okay, while we're at the wrong temp, then keep going until we get the right temp. But we're not doing anything to like increase the temp if it's too, you know, cold, or to decrease the temp if it's too hot. Well, we can create, you know, some stuff in here. So we can say that's too hot, and we can say current cocoa temp equals current cocoa temp minus 5. And so we're going to say that's too hot. And so we want our hot chocolate to cool down. So we say, okay, decrease it by 5. And we can do the same thing for our too cold. We can say current cocoa temp equals current cocoa temp plus 5. So this will inch it closer to our main, the temperature that we want until it's at the temperature and we change our wrong temp to false. And then we actually drink the hot chocolate and it's gone. But this is going to be instant. Like if I press play right now, it's literally, that's too hot, it's going to be instant. What if we really wanted to, simulate this idea? Well, we need to add something that will actually delay our process, and so we use something called sleep. And so after our little try catch here, inside of our while still, we can add time unit dot seconds, and seconds is going to be all in caps, dot sleep, open parenthesis, and we'll do 2. So we'll say 2 seconds. There we go. We have this time unit thing. It's not going to know what it is because we have to import this thing. There we go. And because sleep requires exceptions in case something goes awry, while it's sleeping, then we need to add this little throws thing here, but it will never freak out because we know what we're doing. So what exception is it? We need to check this out. And so we will add throws clause, and it does it perfect for us. And so there are reasons why this interrupted exception would be called. It would be like if we were already out of this method somehow or something like that, but we're not going to have these problems right now. So now if we press play, we say that's too hot. We wait a little bit. That's too hot. We wait a little bit. It's going to do it for quite a while because we want to get down to 185 a little bit. And then it says that cocoa was good and it's gone. So we waited and then it was good to go. What if we do 50? Save it, we'll play it. It's going to say, that's too cold, that's too cold. That's too cold, we need to keep going, and that cocoa was good. What if it's perfect? What if it's 170? We'll play it. And so it's actually stimulating what's going on. So it was good, I drank it, and now it's gone. So why does this work? Well, our window for a good temp was long enough. So if we scroll up here, this is something super important to note. Our temp, like the window, was 15, units. Down here, we add by or subtract by 5 units, and so it's always pretty good in the range. And say if it's like at the edge and it's equal to too cold or equal to too hot, on the next go around, it'll be right inside the correct area. But let's say if this little window of a good, temp for hot chocolate, it was really small. What if it was like, 2? Like it was 185 and 183. Well, then it would just, go back and forth between, that's too hot and that's too cold and never get to the right temperature. So these are the type of problems you should think about when you're writing code. Like, oh, will it ever, if I'm in a while, will it ever get to a case where it exits the while? Will I get a never-ending loop? These are very important questions to think about as a programmer. And so that is it for this video. We implemented exceptions today. We created our own exceptions with our hot chocolate example. And so we had a too hot exception, we had a too cold exception, and then we had a temperature exception that kind of grouped them together, so it's nice and form-fitting. There we go. We learned that we can call our own exceptions and as well as create them. We used this new thing called throw, and we could throw our own exceptions when we knew something was wrong with our programs that we knew that Java wouldn't recognize, where like sort of say a certain value is below 0 or our hot chocolate is too hot or too cold. We created our own exceptions to deal with these problems. With these exceptions, we also had to do certain things with them. So we could either throw an exception with a method saying like, oh, we'll deal with this exception higher up in a try catch, or we could deal with it right then and say, okay, try catch, this is what I want you to do if an error occurs. And so in our drink hot chocolate, we threw the exception and then we eventually caught it inside of our main. So we called this method drink hot chocolate, but it was called within a try catch. And so if like something went wrong, if the hot chocolate was too hot, then we dealt with that exception by catching it. If it was too cold, we caught that exception as well, and we dealt with it there. And we said, okay, make it cooler, make it hotter, depending on what the exception was. And so not only did we find the problem, we also tried to solve the problem with an extra little bit of code. And that's not a pun. You know what I mean. And so that's it for this video. The HackerRank challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.